In the fascinating realm of biomechanics, there's a concept that's as intriguing as it is important: passive insufficiency. This term might seem a bit technical, but its essence is quite simple. Passive insufficiency refers to the phenomenon where a multi-joint muscle reaches a point where it cannot stretch any further. It occurs when a muscle is fully elongated over all the joints it crosses, to the point where it can no longer generate an effective force. Now, you might be wondering, what causes passive insufficiency? The root cause is the inherent physiological and anatomical structure of our muscles. Each muscle in our body is designed to contract and relax, giving us the ability to move. However, when a muscle is stretched across multiple joints to its maximum length, it reaches a point of insufficiency. It simply cannot generate enough force to cause movement. This is not a malfunction or an error, but an integral part of how our bodies function. The effects of passive insufficiency are varied and significant. It can limit the range of motion in certain movements, especially those involving multi-joint muscles like the hamstrings or the biceps. For example, when you try to fully extend your knee while your hip is flexed, you might feel a restriction. That's passive insufficiency in action. But it's not all about limitations. Understanding passive insufficiency also helps in designing effective exercise and rehabilitation programs. By knowing the limits of a muscle stretch, physiotherapists can tailor exercises to ensure they are safe and effective. It helps avoid overstretching and potential injuries, making recovery more efficient and successful. Let's not forget the significance of this concept in the broader spectrum of biomechanics. Passive insufficiency is a foundational principle that helps explain the intricate dynamics of human movement. It contributes to our understanding of how muscles work together to create motion and how this balance can be disrupted by injury, disease, or even the natural process of aging. The journey into the world of passive insufficiency biomechanics is indeed a fascinating one. It starts with understanding the simple principle that our muscles have limits to their stretch. This leads us to the causes of passive insufficiency, rooted in the very architecture of our muscles. We then explored the effects of this phenomenon, from movement restrictions to its role in shaping exercise programs. And finally, we recognized its significance in the grand scheme of biomechanics, contributing to our understanding of human movement. From the gym to the physiotherapy clinic, from the research lab to the sports field, passive insufficiency is a concept that touches all aspects of movement science. It's a reminder of our body's incredible design and how even its limitations are part of a finely tuned system that keeps us moving.